Okay, welcome back to the channel. So in this video we are going to see what is bridge full wave rectifier. So in the previous class we have seen types of rectifiers, definition of rectifier, types of rectifiers are half wave rectifier and the full wave rectifier, and in that half wave rectifier we have seen the derivation also, right? So now we'll see what is bridge full wave rectifier and what is the circuit diagram and what is the working principle and how the waveforms will look like, right? So full wave bridge rectifier is nothing but it is a full wave rectifier, but it is having a number of diodes difference. Now for that you should see half wave rectifier is consisting of how many diodes? Two diodes. Full wave rectifier with center tap, how many consisting of? Half wave rectifier is consisting of how many? Sorry, it is one. Full wave rectifier with center tap, two. Full wave rectifier with bridge, it is four. Now you can observe, I will call it as diode number D1, D2, D3, D4, right? So same thing, transformer is same, primary, secondary is same. It is having a turns ratio N1 is to N2 and AC input, and it is connected to four diodes. It is forming a bridge like structure, that's why the name is bridge rectifier. So two diodes in this direction, diode D1 in this direction and diode D3 and D4 in up direction. D1 and D2 down, D3, D4 up. And here it is having 4 points. The 2 points are connected to transformer, other 2 points you should connect it to the resistance, right? So now we should see how the case number 1 working is. For case number 1 working, so how it is going to be for positive half cycle. If the input is positive half cycle, how it is? Now just look at this, how it is going to be. If the input is given like this, positive half cycle, that is AC, at that time by transformer followed by the diode. So how to write the diode? When it is positive half cycle, so this is plus minus and this is plus and minus, right? So now after this we should think about the diodes. So here it is positive, means this side is positive. If it is positive, which is the positive here in this out of diode D1 and D2, this is positive and this is negative. This is positive and this is negative. So plus and plus is acting as a short circuit, it is forward biased. Plus and minus is acting as open circuit and it is reverse biased. Hence, what you should do is you should connect this diode and you should make it as open circuit, right? Similarly, you can observe here, I will be having minus here, means this side it is minus here. So this one is acting as minus and minus, so it is forward bias. So here this diode will be present. What about this minus and it is plus? It is reverse bias, hence it is open circuit, right? So I will write here diode D1 and D2. What about diode D3 and D4? Those are open circuit, right? So this is same. Right? So this connection is here, right? Now how the current is going to flow? How the current flows? It will start from positive end, so it will go like this. So I will take the other color so that you will understand. So it will start from here, through the diode D1 it will go. It is open circuit, it will not go here, it will go like this. So it will go through RL, right? It will come here, go up, again here, go here. It is open, it will not go here, so it will come through this diode D2 and here finally it is going to reach the negative point, right? So through this what you will measure? You will measure VDC, right? So the current I is flowing through the two diodes, diode number 1 and diode number 2, right? So this is the point. And here what is the output you are going to get at this stage for positive half cycle? So this is what you will get. It is VDC, right? So we'll see for the case number 2. How the case number 2 is for a negative half cycle of input. Negative half cycle of input. So what exactly happens? Same, take the transformer, primary, secondary. So now think about which are the diodes which are going to be forward biased and which are going to be reverse biased, right? So if it is negative half cycle of the input, V in is negative, at that time this becomes negative and this becomes positive, right? When this is negative means when this becomes negative and this becomes positive, and this is negative, which is now negative, this one, so it is a short circuit. So I will draw the diode here, right? And what is the one more? Minus, and here which one is we can take here? So it is plus, plus and plus, so this is forward biased, right? So what about the other two? Other two are reverse bias. So which are the diode numbers? Diode D3 as well as diode D4. Here D2 and D1 are off, right? So how the current direction is? Current direction will start from positive. So where it will go? From positive here, this point, from here through diode D4. Then after that it is not going up, it is going down, and it is going through RL. So it will come up, and here it is not going through this, it will go through from here to D3. Then after that it is going to finally reach here, right? So this I will call it as VDC. Right? You can observe here, you can observe the direction of the current which is through the RL here and also here. How the direction is? The direction is like this. Here current, and here also the direction is like this. The current direction is same whether you consider the positive half cycle of the input or the negative half cycle of the input. Hence, what is the output you are getting is, for negative half cycle also you will get the same VDC. Correct, right? V I and V both are same here. V directly proportional to I, right? So this is case number 1 and case number 2. In both the cases, it is working, right? So after that, we should draw the waveforms. How to draw the waveforms is, just look at here. Here 2 diodes will work at a time. So that advantage we will take for the bridge rectifier. So how to draw this? How to draw this? First draw the input, 1 cycle, 2 cycle, it is T, plus minus, right? This is V input. Then after that, what is the next one? The current I is passing through the case number 1, that is through this cycle. So which is the diode which is going to be on now? Diode D1 as well as diode D2. If this passes, if positive passes, what is the result I am getting? Same I am getting, positive, right? But here, what are the diodes which are on? Diode D1 and diode D2. So I will write D1 and D2 are on, right? So I will write this as VDC, right? Next, after that, what about the next negative cycle? Negative cycle, which are the diode which are on? D3 and D4. What is the result you are getting? Again, same. So this you can write diode D3 and diode D4 are on. What is the meaning of this on? Means other 2 diodes are off. Similarly, this pattern's same, right? So this is a overall. This is the overall. Suppose I am writing only for the case number 1. Only for the case number 1, at the time it is like this. For positive, like this. For case number 2, for negative, like this, right? So this is the combination of both case 1 and case 2, where we will call it as VDC. The output is looking like this, right? Now, in case of half wave rectifier and full wave rectifier, we have taken a capacitor filter. To improve that, we should get AC to DC. So here whatever we got, this is not the purest form of DC. So it is called as pulsating DC, right? Purest form means we should get like this, right? So in case of half wave rectifier, full wave rectifier, we have added one capacitor here across the resistor. So we called it as C, right? If it is the case, what is happening is, for the case number 1, if I add this capacitor, it is acting as, because of this diode D1 and D2 is conducting, the capacitor will start charging. Capacitor will start charging and it is going to reach to the peak point, right? Once this input falls below, so that this capacitor will start discharging. Again it is charging, discharging, charging, discharging, charging, discharging. So you are going to get the waveform which is like this: charging, discharging, charging, discharging, charging, discharging, charging, discharging. So we call this as charging and this as discharging. So this is capacitor voltage. So this resembles the constant VDC, but not is not. So this pattern we will call it as by the name, and that name is called as ripple, right? So the number of, it is a measurement of the number of AC content in the DC output, that is called as ripples. So we should measure this ripples. So in case of half wave rectifier, I have taken this ripples. That ripples factor is measured with the help of 121% in case of half wave rectifier. So this ripple factor and efficiency we have spoken with respect to half wave rectifier. What is the ripple factor of half wave rectifier? 121%. And what is the efficiency of half wave rectifier is? It is 40.6%. So this is the drawback of half wave rectifier. So we move to the full wave rectifier, whether it is center tap or it is bridge. We should improve this ripple factor as well as we should improve the efficiency. What is the meaning of improve the ripple factor? You should decrease the ripple factor. What is the meaning of improving the efficiency? We should increase the efficiency. So if we work out this, so we will get here it is approximately 48% and it is 81%. So we will do this in the next class, how exactly the ripple factor and the efficiency of full wave rectifier. So here this is how the working of bridge, full wave rectifier with respect to the circuit diagram and the explanation in the waveforms with the capacitor filter also, right? Thank you. We will see in the next video the next topic.